In this video, we're going to get an introduction to our logic and reasoning unit of geometry, which is going to involve statements known as conditionals, and we'll see some other things with those, such as counterexamples, something called a converse, and a biconditional. But before we get too far into that, we're going to look at a couple concepts here. One of those is known as a conjecture, which is simply an educated guess, something that we draw from observations and inferences. And one way you've experienced this in the past would be looking at patterns. And so you see a diagram down here that has multiple steps, and each step in the pattern seems to have more stars in it. And so what we can do is we can see how many stars are in the first few patterns, maybe draw some inferences from there to help us determine how many stars would be in future figures. And so one way to do this might be to make a list of what you see. So you see that as far as the first figure goes, there's only one star in that. In the second figure, we see 4 stars. And the third figure, we see that there are not just 4 stars like the first one. There's those 4, but then you have 3 more groups of them. So that would be 4 groups of 4. So that's 16. And from this point, you could maybe try to figure out in different ways how to determine how many stars would be in the next one. One option might be you see that we have this same group here contained over here. And not just that one time, but there are 4 different sections that have that many. So if there's 16 in this group, there would be 16 in each of the 4 groups within this whole picture. And 16 times 4 would be 64. Now, another way you might get that, seeing that these are squares, you might see that there are 8 stars in the row, 8 stars in the column, so in total 64 stars as well. But the conjecture would be based on a pattern. And the pattern might be the visual that we were talking about, how many groups are contained within, or it might be an algebraic operation that you're seeing. So we might see that to get from one term to the next, we can multiply by 4. So that we have this conjecture that the pattern is to multiply by 4. And if that's the case, then that might help us get to this last pattern that is not drawn and honestly would take us a while to draw. All we have to do is take 64 times 4 according to the pattern that we see, and we should end up getting a total of 256 stars. So that is the idea of a conjecture, not a random guess, but rather an educated guess, something that's built upon observations that we have seen to be true. So as far as things being true for us, we have something called a counterexample. So what we're going to see are a lot of statements being made as we go today. And in those statements, at times we want to determine whether the statement is totally true or not necessarily true. And so we're going to get rid of this gray area. We're going to say that a statement is either true or it's false. But what we have to understand is false means that it's not always true. So true means true always, no matter what, hands down, this is the case. Saying that something is false means, yeah, it could be true, but it doesn't have to be true. So what we're going to see down here are 4 different examples, and all we want to do is provide what's called a counterexample, which is just a concrete example of why this is not necessarily true. Okay, so we want to avoid being very vague about it. We want to give an actual example. And so this first one, we see that the statement says every room in the school has a U.S. flag. That is a statement, and that's one that we could evaluate here. And if you think about the rooms in the school, yes, classrooms gonna have a flag in them. Offices and the cafeteria, they have flags present, but maybe, so it seems like it could be true. But if you think about it, I think we would all agree that bathrooms do not typically have a flag. And that would provide a concrete counterexample for us. So we can say a counter to this would be bathrooms do not have flags. Okay, so there is an example where that statement is not necessarily true. Like a counterexample. So we can try this with the other three. One that you may or may not know, it says all presidents have been men. And the tendency is probably to say true because you're thinking US presidents. But as you notice, this says nothing about the United States in particular. So we want to read carefully about what is being claimed. And in this case, it's just presidents in general. And so I gave a link here because depending on your background in world politics, um, which may be very limited, which is okay. I gave this link to some examples here, some women leaders throughout the past. And there are some cases of um, some women who were presidents, such as here in Argentina back in the 70s, and here in Bolivia as well. And there's quite a few more. So on what we can do is we can choose any of these people that were considered a president. So if we took Agatha Barbara from Malta, there's a concrete example of someone who was a president and was not a man. So that would be a counterexample for our statement that was made. And so our quick counter here would be about Agatha Barbara was the president of Malta. Now, if we want to get really technical about this, we didn't actually see anything about countries, presidents of countries. So I don't know. I guess we could talk about student council presidents and class presidents as well as counterexamples there. Okay, for example C, just another case here. I before E, you've probably heard that before when you're spelling words. If you have those two words together, we put I before E except after C, which even that rule doesn't hold true. In this case, we could think of any word where this is not necessarily true. And I provided you with several that you can view right here. So take your pick. Take your pick in there. Lots of words to choose from. And I'm just going to stick with the last one, weird. That is one example that goes against the claim that I had to come before E. And so there's my counterexample that I will include. And so there's my counter. We're just going to include the word weird here. And that is just one instance of where that statement does not hold true. And so we've provided an argument against it. And all of those involve words, you might notice. But our counterexamples don't always have to have the words. Oops, I lost our weird here. Let's put that back. Okay, there it is. Sometimes we can just draw a picture or a diagram, and I think that'd be pretty appropriate for this last one that makes the claim an acute angle has a measure less than 45 degrees. While, as you think about it, that is true. Any angle that's under 45 degrees and above zero is going to be acute, but that's not all of the options. Acute actually means any angle that has a measure less than 90 degrees and is positive. So what I can do is just draw a quick picture here of an angle that looks acute. And to counter against this claim within that angle, I'll just put a measurement down. So any measurement that is considered acute but above 45, such as this one, 55 degrees, that would be an argument against the claim that was made. So there's our counterexample through a diagram instead of through words. Although we could have explained that same thing through words. Okay, so those are counterexamples. We're going to use those soon to determine truth value to a statement. Something we need to talk about is what our statements are going to look like. So conditionals here provide a condition, and that's where the name comes from. And conditions have two parts, the beginning and the end, which we'll call the hypothesis and the conclusion, just like a scientific method. You make your hypothesis, and then you end with your conclusion. So conditionals, they can say all kinds of things, but there's always a setup at the beginning and then some kind of claim at the end. So we could say something along the lines of, if everyone scores really well on the next test, then we will have a free day pizza party. We had those two parts. The first part being everyone scores, whatever percentage on the test. And then the conclusion, the following part to it, would be the pizza party and free day. So these conditions, they set us up. And we're always going to write them in this form of starting with if to introduce the hypothesis, and then having then to be followed by the conclusion. And not only that, but we're also going to use letters to represent these things to help us stay organized here. And for some reason that I don't know off the top of my head, we're going to use the letter P to represent the hypothesis. And since the hypothesis is followed by the conclusion, we'll represent the conclusion by the letter that follows P. And so the conclusion will be represented by the letter Q. And when we write these statements, when we start with a hypothesis and end with a conclusion, in symbols, we'll put P before Q, and we'll end up drawing an arrow between them that shows that we started with our hypothesis and ended with our conclusion. Might be a little confusing as to why we're going to be doing that, but pretty soon we'll see that it's going to help us, and it does tie things together. So our sentence structure is this. We'll see our two halves. We'll have our introduction with the word if, and then the conclusion will follow the word then. But as we know in the English language especially, we have a lot of words that can all mean the same thing. And so sometimes we'll have statements that aren't given in that format. And our goal is to rewrite them in that format. We're always going to try to write in if-then form. So there are some words that are synonyms to the word if that I've listed here for you. So what we need to know is anytime we see any of these words, they are our introductory word for the hypothesis. And so if we see the word when, we'll just realize to replace it with the word if instead. Same goes with any of these words in this column. Now over here, we also have words that are synonymous with then. And some of these will be fine, and we won't see them necessarily that often. The one that's most confusing tends to be this one, because you see it uses the word if within it. But when you pair these two words together, only and if together, that is actually for our conclusion. And so we can replace those two words with the word then. And sometimes we speak and write sentences that don't involve these words. We do this all the time, don't we? And so, in those cases where we are trying to write a sentence that has two halves, a beginning and an ending, and we don't see these introductory and concluding words, to find the two halves of our statement, we're just going to look for the verb, whether it's an action verb or a transitive verb. Okay, so what we need to do now is actually work with some of these conditional statements. So now that we have our setup and we're seeing some of the symbology, let's go ahead and go to the back here of these notes and talk about our conditionals. So our goal is to write conditionals in if-then form, and there's that notation that we were talking about, starting with P and ending with Q. And so we have some rules here. We're going to write as singularly as possible. We're going to have a subject to our sentence, and we're going to use the fewest number of items or things as needed to talk about that subject. And we'll always make sure that we have a hypothesis and a conclusion. And when we write those, each should be a complete sentence on its own. Pronouns are natural to use in our statements. We're going to want to keep our pronouns to the second half of the sentence always, so that we always know what our subject is in the beginning, and then we'll know what pronoun is describing it later on in the statement. So it'll start clearing up as we go through a few things here, I think. And our first case is a statement that says all dogs are nice, a very simple statement, and whether or not we agree with it, we'll get to. But these four words actually represent two themes, and that would be the two halves of our statement that we're going to create. So we can look for the keywords if and then. We don't see those. We can look for synonyms to the words if and then. That would be in the table that we saw before. And none of those are present either. And so our strategy in that time was find the verb of the sentence, and that verb is the word are. And when you find the verb, something you can do to get a visual here is draw a dividing line through your sentence right before that verb, and there's your two halves. We have first half of our statement talking about dogs, and the second half of our statement talking about being nice. So pretty far from being a conditional statement with our two halves. We have slight work to do. And so what we need to do is get started here with our first half and structuring it as a completed sentence on its own. So let's take a look here at maybe the wrong approach to this. First approach would be we want to write the statement starting with the word if. And so we're going to say if something. And if we just purely go with what the sentence says right here, our statement would say if all dogs for the first half. And then the second half would be then are nice. And I think what you're going to realize is that just doesn't make much sense. There's a lot lacking here to a proper sentence structure. No one can read this and really know what's going on. And so our goal is to make this a little bit better. So let's go back to our first half where we just said if all dogs, which wasn't quite a complete thought here. So what we need to do in these scenarios is we see the subject is dogs, but we need to think about what a dog is. Is it a vegetable? Is it an animal? Is it a person? And obviously it's an animal, but that's the idea. What is your subject? What classification is it? And in this case, a dog is an animal. And so what we can do here is to make a fuller thought is write this as if an animal is a dog. So now we're getting a little closer to having a nice completed conditional statement. If an animal is a dog, and now we can fix the second half to finish this out. We're not going to say then are nice, but we can say then it is nice. So our themes are still present. Our first half still talks about being a dog. Our second half still talks about being nice. And we were singular about it. We only need to have one dog to talk about this particular animal. And the word it, the pronoun it, would correspond to a singular subject. Okay, so if an animal is a dog, then it is nice. We'll get around to whether or not we agree with that. Before we do, let's look at dissecting this. So recall, we use P to represent the first half of our statement. So we see that P was the beginning of this conditional, and that would be what we say here after the word if and before the word then. So our hypothesis P is simply the statement that an animal is a dog. So on its own, that is a full thought, which is good. And that's what we'll put here. An animal is a dog. And I got that moved on to the line. So a complete sentence right there. And then what we need here is the rest of this sentence. Q, our conclusion was it is nice. And so if we add in that statement here, don't use the word then, just include your conclusion, which happens after the word then. It is nice. That would be the full sentence structure. And so P and Q are well constructed statements, and we're good to go there. So we have a nice full conditional statement. Now you're going to see we have another blank down here, but we've reversed the orders of P and Q. There's a statement that we're going to talk about that starts with the letter Q and ends with the letter P. So in other words, it starts with your conclusion and ends with your hypothesis. Well, our conclusion was it is nice. And our hypothesis was an animal is a dog. And so what we're going to do is we're going to start with this part. But the confusing part to this would be that, one second. Okay, so the first thing we're going to do is we're still going to start with the word if. And if we just purely did this, if we just put Q after this, which was it is nice, and then we went to then an animal is a dog. What we want to do to fix this is this whole pronoun issue. So right now the pronoun is in the beginning. And so if we just looked at the first half of the sentence that said, it is nice, we don't know what the word it is describing. Is it describing this animal? Is it describing an ice cream cone? I don't know. A person? I don't know. And so what we want to do instead is instead of having the pronoun at the beginning of a sentence, what we want to do is keep that pronoun at the second half and always keep our subject at the beginning so we know what the subject is. So even though we used an animal for P, that wasn't the theme of P. The theme of P was about being a dog. So we'll keep whatever the idea of being a dog is with the concept of P. But we're always going to keep our subject in the beginning, and then we can use the pronoun at the end. So this sentence will read, if an animal is nice, then it is a dog. Okay, so that is a case of just reversing the order of what a claim made. We have this other case that has double arrows, and what that would mean is what's set up here is okay to say in both directions. It's okay to make the claim by starting with P and having the arrow go over to Q, but it's also valid to start with Q and ending with P. Well, to decide that, we need to see whether or not we agree with these statements. So the first one here, we have to determine, is this conditional true? If an animal is a dog, then it is nice. Well, if we wanted to argue with that, we'd have to think of a case where we have a dog and it's not nice. And maybe you know a dog personally that's not very nice. Maybe you even know a breed of dog that's not very nice. For a literary example for you from Stephen King, there's a dog, Cujo, that tends to not be the nicest. So that could be a counterexample for us. And we can abbreviate counterexample just by the letters CEX. And we can just simply say Cujo is not nice. Okay, that's a concrete example. Remember, we're not just going to say, well, some dogs aren't nice, because that's not an actual example. That's just a thought that you had. A counterexample needs to be concrete, something we can all agree upon. And so we already said this one is not true. We could also think about the second example down here. If an animal is nice, then it is a dog. Well, this claims that all animals that are nice are also dogs. And maybe you can think of other animals that are nice that are not dogs. And one that crossed my mind that I thought was pretty nice, and maybe I'm wrong here. I thought manatees were pretty nice. And so I was going to provide a counterexample against this claim that manatees are nice. And again, giving a specific example, not some vague description of other animals could also be nice. This is an exact example. Okay, well, here's the whole idea. If we don't agree with both this conditional, P to Q, and this conditional, Q to P, then we cannot agree with the double arrow that says both are true. And so in this case, we're going to leave that blank. We cannot complete this one because it's not valid to make the claim in both directions. Actually, in this case, it wasn't valid to make the claim in either direction. Okay, well, that's one way this could happen. Just a couple more examples here, some quick things. We have another claim that's made that says an angle of 40 degrees implies it is acute. Now, you notice that there is no word if in this and no word then. And that is how we want to write our statement. So when we read this sentence, we're going to look for keywords. And one of those keywords is present. It's the word implies. And if you go to the table from before, the word implies is a synonym for the word then. So when we see implies, which we don't want to use, we want to use what it's a synonym for. We'll use the word then here. And the good news is then is the introduction to our conclusion. So our second half is always after then. So this sentence is in order. Here's your second half, and then your first half would be here. So we don't have to try to rearrange anything. Our conclusion is already at the end. Now we need to do some things like we did before. We need to alter this slightly to make it a nice if-then form. And what we can do is look at this. The subject is about being, the theme is about an angle of 40 degrees. And so maybe a way we can approach this is making a statement here that starts with if. So if, and then it wouldn't quite be valid just to say an angle of 40 degrees. Maybe you say an angle is 40, and I don't have a degree symbol, so I'm going to type it out. If an angle is 40 degrees, that's not quite maybe the most proper way to say that, although we definitely know what you mean when you say it. Technically, we're talking about the measure when we talk about 40 degrees, so we could say if an angle measures 40 degrees. There are some options here. There's not necessarily just one right way. But then we follow by the conclusion, it is acute. Okay, so we have two full thoughts here combined into one conditional. So that first thought, our hypothesis P, is an angle measures 40 degrees. And our second claim, again, was that it is acute. And so right here for our conclusion, we'll put it is acute. We have two statements on their own, here and here. And so we have a nice structure then. And so our next task is, can we write this in reverse order by keeping the subject in the beginning and the pronoun in the end? I think we can. No matter what order we're putting things in, we do need to write a conditional that starts with the word if. And so down here, we'll start with if, and our subject was an angle. We only need one angle to be acute, so we're keeping this singular. If an angle, and now we can talk about the theme of our conclusion, which was simply just about being acute. So we can say if an angle is acute, then, and now we can throw our pronoun in. We just have one angle, so we can use it. If an angle is acute, then it, and what was our theme for P, which is what we're ending with now. And the theme for P was about this angle measuring 40 degrees. So we can just simply say, then it measures 40 degrees. Okay. And so what we need to do now is determine the validity of these, because our last part here would be, is it true in both directions? That's why the double arrow is there. Well, we can go up to the top and see, was the original conditional valid? So it says, if an angle measures 40 degrees, then it is acute. And I think we're probably going to agree that is true. So for this first claim, we have a true claim. Okay, so we're part of the way there. It's valid to start with P and end with Q. Is it also valid to go in the other direction? Is it valid to start with Q and go to P? Well, when we do that, we get a sentence that reads, if an angle is acute, then it measures 40 degrees. And you could think about that briefly and realize that is not necessarily true. While this is a case of an acute angle, there are lots of other angle measures that would also be considered acute. So when a statement is not necessarily true, we are going to claim that's false. And so we have a counterexample that we can show. We don't have to write out words, although we definitely could. We could explain it in words why this isn't true. But a perfectly acceptable approach to this would be show an acute angle that has a different measure from what was described. And so maybe you just pick 50 degrees for that example, but this would be a counterexample to the claim made. And just like before, if it's not valid to go in either direction, then it cannot be valid for both directions. And so in this case, it was okay to make the claim here. It was not okay to make this claim here. And so we will not use this case that has double arrows. We're going to leave this one blank. Okay. So one last case here for a different idea, and a lot of it pertains to our subject that we'll use. The claim here is that perpendicular lines form right angles, and I think we can all agree with that at this point. But as we think about this, we don't see the words if or then, and we don't see any words that represent those words. And so we look for the verb, which is the word form, and if I draw a divider line, we see our first half and second half. And the first half simply says perpendicular lines, and that's it. There's nothing else about it. And so we do have a job here to write this conditional using that theme about perpendicular lines, but we need to talk about the subject. So one thing is to think about how many lines does it take to have perpendicular lines? Well, the bare minimum is 2, and so we'll use 2. So the way I worded this was, if 2 lines are perpendicular, notice it's okay to use numbers in our statements in here. It's also okay to use symbols for the words angle and maybe the words perpendicular or parallel. We have some symbols that we can apply. Totally fine if you want to do that. But we got our subject. We have 2 lines that are needed to be perpendicular. And then we're going to end with they form right angles, which is true. I put this 4 here because technically 2 perpendicular lines would make 4 right angles always. So that is true, but if you just have right angles, that would be fine as well. So I have our hypothesis here. 2 lines are perpendicular. There's a case of that right here. That is P. That's a full thought. And so now we need Q, which is just our conclusion here at the end that says they form 4 right angles. And so we'll put that here. And whether or not you include the 4 is up to you. They form 4 right angles. And so we have our second half to our conditional. Okay, and again, both of these are full thoughts on their own, 2 complete sentences. So we had a good structure. And then our task now then is, can we write this in the reverse order? So just one last time, remember we always start with the word if, and we always keep our subject at the beginning. So our subject from before was 2 lines, except now what we'll say about those 2 lines is whatever Q had been talking about, our conclusion. And that theme was about having 4 right angles. And so this time we'll say if 2 lines form 4 right angles, then, and now we can say they would be appropriate for the pronoun here. They are perpendicular, which was the theme of our hypothesis P. Okay, so something else that's going to be different this time is when you analyze these, P to Q, the original conditional said if 2 lines are perpendicular, then they form 4 right angles, and that's exactly what perpendicular lines do. When you have perpendicular lines, they will form 4 right angles, and so that is a true statement. It's valid to say that. And then down here, we have if 2 lines form 4 right angles, then they are perpendicular. And if you think about that one, that's also true, because if you have 2 lines that are making right angles when they intersect, then those 2 lines are automatically considered perpendicular. to each other. And this is finally the case where we see it was valid to make a claim in this direction as well as this direction. And so we have this option to do a double arrow instead when that happens. And so when we have that case and we want to write this as a statement that could be said in either order, like we did up here, it's actually pretty simple. You notice it starts with the letter P here. So we'll take what P had said. So P made the claim that two lines are perpendicular. So I'll put that here. Notice I'm not starting with the word if in this case. So two lines are perpendicular. And now before I get to my second half of this statement with the conclusion, we're going to put the IFF in the middle. And this means if and only if. In other words, what we're saying is that two lines are perpendicular only if and only if. So the only way this can be true is if the next part is also true. So two lines are perpendicular if and only if they form four right angles. If they didn't, then they wouldn't be perpendicular. So this if and only if, it's very strong of a statement, and it says that this is true in either direction. So the only difference here is we still start with P, we still end with Q. It's just we won't use the words if then here. We'll put this IFF in the middle, which stands for if and only if. So that's called, that statement has a name that we're going to see below. Actually, both of these have a name, but let's look at this and realize what we did was start with two separate conditionals to determine if they're true. And once we knew that, we wrote it in this form. We could do the exact same thing in the opposite order. When we see this first, we could always go back and write it in these two formats. So notice P is always given here in the beginning, Q is at the end. So if you were given this claim and you needed to write a statement in this order, you would simply just put if before this half and the word then before that half. And then you just do that in the opposite order for the Q to P, which have their own names. Like I said, we have a name for this Q to P where you just reverse the order of the original conditional. It's called the converse, and we'll talk about that more next time. Something to note is that it can be true when the conditional is true, but it doesn't have to be true when the conditional is true, which we saw up here in this example. The original was true, but the converse was not. So those two do not always have to agree with each other. However, when they do both agree, this last statement that we write for the double arrow that's true in both directions, that's called a biconditional statement. The prefix bi simply meaning two. So biconditional means two conditionals. You can make two conditionals out of it in either order, from P followed by Q or starting with Q and followed by P. And so what's important to know about the biconditional is when you're given a biconditional, then both the conditional that you write from it and the converse that you can write from it are guaranteed to be true. So that's what we're going to leave this with as an introduction. What we're going to do next time is apply a little more to these statements and talk about a couple more of them.